let's try with the PowerPoint and we see because. Okay. Hello again, everybody from my side. I'm glad to be here with some very good colleagues and in this very nice project, this very nice initiative, the Neutron, which is coming into the end. And of course, as we said, we hope that this meeting can allow us, can give us the boost we need in order to have a follow-up and in order to communicate and disseminate the results of the project. So I will try to put Neutron into, let's say, a wider context, and I will try, even though I will speak about technical issues, not to be very detailed, but to give the overall impression, and the overall impression about the next, its prospects and challenges, how we can shift actually to the greening of the district heating network. Of course, having systems like Neutron is something very important, but there are other also things that we have to do on the background and on the infrastructure in order to move on. So I will try to give the impression of these factors, and of course this is not my work, this is a work at our lab, and it's a collaboration with the electrical engineering department also. So, and also Leonidas Zouloumis, a PhD candidate, is working hard on this. So, yes, Yannis, maybe I can go to the next slide. Okay, we all know the general framework. We know that the national, energy and climate plan, we want to go to a wider penetration of RES, especially in the heating and cooling sector. This is a critical thing because we talk about in electricity things perhaps can be more simpler due to the easiest transmission and storaging, but the heating and cooling sector is one sector that we also want to increase the penetration of RES. We know about the city of Kozani. We have talked a lot about the district heating system. I will not go into detail, so Yannis, please, let's go to the next slide. And the next slide is these three pillars. You can see here how to encourage RES participation in district heating networks. So one pillar is utilize DHN, district heating network flexibility. Flexible energy systems, it's a modern term that it's used nowadays. This term aims to demonstrate the ability of the energy system to cope with, to match. At one hand, we have the demand, at the other hand, we have the supply, and we have to be sure that these two are in line. And this is a very big challenge for an energy system, after all. Of course, we can, heat capacity of buildings, heat capacity of the thermal network can be important. Mostly important is the control strategies on this issue, and I will talk a little bit about control strategies. The second thing we also discussed, and I think Vasilis made some mention, it's on the climate, it's how to lower the operational temperatures in the network. This has to do with the terminal units we have. In Kozani now we have heating radiators, let's say, and also this is also involved with the insulation, as we discussed. So this also is something important, especially if we want to include a variety of technologies in the network, but to increase also the effectiveness of simple technologies like Neutron. Lower temperatures at the end will help. And the next, energy hubs. It has been discussed also here. We are trying to promote energy effective solutions, and maybe the solution would not be only one. We want to have an energy hub. This would give a diversity to the system. This would give energy safety. It's an open discussion, and we work towards also this direction. The challenges, we have the controlling challenges, I would say. I mean, controlling is a major factor on what we talk about, and together with controlling, we talk about how to cope with the, after all, the individual needs of producers and its consumer at the end. And we see, in terms of controlling, how we try to develop a communication and a communication tool in order to match the different needs of producers and consumers. I will show you the framework later on. And of course, when we talk about control, and especially today, we have to predict and forecast. This is very important. And also dimensioning. Okay, we have control, but dimensioning is also very important because you have to have the proper dimensioning in order to optimize the operation. And of course, multi-energy structures should be developed at the end. So we have to develop tools that address these challenges. Of course, there's also a main challenge I didn't talk about. This is the finding capitals. It's not only knowing the technology or having developed package solutions, but we need also for the city, for our city, and this is a good point to stress it. We have to find capitals in order to implement, because now we don't talk only about pilot projects, but we talk about the everyday life of a city. Okay, that's very important. Yes, please, Yannis. Now, two things about controlling strategies. Okay, the monitor, in terms of monitoring, it's very important to put something here now. We have to monitor in detail what the demand of every house that participates on the district heating network. This is a very important infrastructure that has to be installed and deployed. Okay, in terms of controlling, we can talk about peak saving. That means that, and we have peak saving now with the photovoltaics. We give various incentives to people when they are at work. We say, okay, you have to go home and put the laundry and then go back to work and that stuff. I mean, we had the night operation by some years ago. Now the PPC in Greece gave us some opportunities, some incentives to increase our load also by noon time. Load shifting, of course, it's important. And the challenges on this, as I said, monitoring requires sensor placement. That's important. We have to put sensors. And also we have to transmit this information. We see how, this is very important. Okay, the strategies have to be developed. We have to see these control strategies and the tools have to be accurate, flexible, easy to implement. I don't know, we can also find some other words to describe the effectiveness of these strategies after all. Yannis, we may. And at the end, we have, as you see here on the left side, we have the monitoring aspect. I will talk about this hardware platform there that we have developed at the university in collaboration with the IAC in order to take the data from the thermal meters that are in each house. We have the monitoring aspect, we have the controlling aspects. It's somehow complicated, I will not go into the detail, but what we want to do after all, we want to implement these that you see on the left, the control and monitoring features we have, where in each house, that is the demand side, but also on the supply side. So we need to do, to applicate, as we see, this thermal load management. Yes, Yannis, we may go on. And in order to be more specific, what you see here, I told you it will be somehow technical, this, but in order to be more specific, what you see on the upper left is a module we have developed, is a monitoring device based on Arduino with some it communicates with a module of the Kamstrup heat meter that the IAC uses. And after all, this allows us to have online data on a cloud for its, if this is installed, it's very cheap to be installed and it can give us the data that we need. Online hourly data of each house, and you see on the bottom right, just to see, this is the heat exchanger. Here on the left is what comes from the IAC, And on the right is what we have in each house. So we have to measure flow rate, temperatures. We need all this information. Sorry for this, but we need all this information after all. Okay. And what I told you, the basic idea we have, and now this is what also Leonidas is working on his PhD, and we have worked with this with the IAC. The basic idea is to do a coordination between consumers and producer. That means that on one hand, you see on the right part, you see that we have the energy producer. The energy producer would give to the consumer the information about the energy price and about the heat load availability and the schedule. This is not fixed, but this is the information flow. The consumer would see the potential, the opportunities he or she has, and he would decide, because here we have some I would say hard constraints, which is that the producer has a specific amount perhaps of energy in this price, and the consumer perhaps needs to be thermally, on thermal comfort conditions. These are, let's say, hard constraints, but there are also some soft constraints to the degree that each one of them can also, perhaps the consumer can say, okay, some needs that I have for now, I can give them for later on, or something like that. So, after all, the consumer takes the information from the producer and then gives the producer how he wants to behave. And then the producer has to readjust on this. So, what we are trying to do, on a dynamic energy market, a dynamic communication between consumers and producers. That's the concept. And okay, this is also the concept. On the right, you see each house, how we can implement controlling and simulation tools in each house, and how these we have on the left side, we have the thermal energy provider. The provider gives the information to the consumer gives the information to the provider, and we have this loop after all. And in order to do this, because in order to realize this, we need some tools. And in these tools, there is surrogate modeling. Surrogate modeling is a term that it's used nowadays. It's something like regression models, not, let's say, physical models, but regression models, machine learning models, neural networks, that are models that their main characteristic is that they are very light on computation, and they can be installed and adjusted to a controller, to a simple controller that we have in our house. They don't need the CPU that a complete or a detailed digital twin, I can say, or a detailed simulation program would need. Okay, I will not go into the detail, but we need surrogate models in order to simulate the building behavior, the heat energy system behavior, and then try to match up these things. It's a pity because it was a video that, you know, one image or one video is 1,000 words, as we say in Greece, but okay. So this is an example from our lab. As you see on the left, this is a chamber. This is a testing chamber. It's 4 meters to 4 meters to 4 meters in dimension. It exists in our lab, and we can simulate indoor conditions there with an air conditioning system, as you see on the bottom left. And you can see also the air ducts. All these there are air ducts in order to control thermally and also control the indoor air quality. And what we have done, we have put this system, the building and the air conditioning system, into a surrogate model. That means that we have developed and we have trained, this is very important, with real data, we have trained this surrogate model, which is very light, and it can be integrated into these controllers that you see on the upper, these very cheap controllers that you see on the upper middle. And what we can do now, this controller can decide what. I will tell you what is the problem and what we try to realize there. This is an office. That means that at 9 o'clock we have to have 20, we are here, at 9 o'clock we have to have 20 degrees. What the controller does, it takes the information from the outside conditions and from our scheduling, and of course it has incorporated the building characteristics, and it calculates at what time by night time this system should go on, should be on, in order when the first person comes here to have here 20 degrees. This is very important because it ensures thermal comfort at this place on one hand, while at the other hand, we don't lose energy because the system does not have to operate when we're not here. And this is just an example of how AI and prediction can be integrated on the demand side, on the controlling of a single consumer. And I was tempted to put the example of Oslo also, because Oslo is a very good example. Okay, no problem. Oslo is something I would say when we went to Oslo, we said, okay, we would like to have a system like Oslo in Kozani also. As you see on the left, we have many technologies. We have waste, we have heat pump, we have many technologies for Oslo, and on the right is the map where we have these different stations. We talk about a system which is 6 or 7 times the system of Kozani in heat capacity. And Yanis, if we go to the next slide, we can see what I was telling you. We can see how all these different sources of energy are integrated on the energy system, and how at the end they cope with the demand. Of course, the demand is higher by winter time. We see that at summer we have we have lower demand, and there are some excess of energy by summer that Oslo would like to put it. It's the load shifting. I tell you, they would like to put it on the peaks of winter time. Okay, this is just an example to show, and of course, this operation would not be feasible if they don't have a good monitoring and control system. This is I don't know if this is the energy hub. This is the next step in Kozani. I think we didn't discuss it that thoroughly today. We discussed it, but we didn't show it. This is the Kozani needs, the Ptolemaida needs, and the Amido would be integrated on an energy hub. We would have natural gas, electrical heater, cogeneration, and we are looking now, we are trying to integrate the rest, the renewable energy sources. Final slide would be something like this. This is our goal. What we want, as I told you, what we want to do is we want to help contribute with, we as a university, but all the partners here with the different disciplines, and each one of us can be important in this very difficult way, I can say, this difficult path. This is the energy hub. On the left side, we have different systems. We talk about how we can take advantage of photovoltaics and electricity transformation to heat. This is the case of Neutron, for example. We have also other technologies that can help on this: solar collectors, heat pumps, biomass, waste, and of course we have more traditional technologies and natural gas. I put it at the end. I was tempted to put it at the bottom. I tried to give a little bit qualitative priority on this. Of course, we need storage. We need storage, seasonal storage, short-term storage. Neutron has a big advantage. I think one of the main advantages of Neutron is the storaging system, because it gives storage on thermal and on electrical level at the end. This is very important, the storaging system. We talked about the prospects. The energy hub is something very important. Thermal energy management strategies are critical for this. Monitoring is the first step, and then controlling. And of course, we have to low temperatures. I hope these Execonomo and all these decarbonization initiatives will go on in order to contribute to the majority of the building stock in Kozani and in Western Macedonia. And of course, we have a lot of challenges. The challenges are related to the way that we have to work hard in order to implement and develop the correct controlling options, to develop these systems. And okay, I didn't put in the challenges, I didn't put, as I said, of course, financing is a great challenge, but our work also as a university is to propose, to demonstrate that we are able on a technical level to give the solutions. So if the society, in order to offer them to the society, given that we have the right occasions, something like that. Okay, I was very happy to be involved in Neutron, and with my friends from Jülich and from Kraft and Lagen from Germany, that we have them here also today, with all the partners, with Yannis, with the Adima. I'm glad that Vasilis also from Klub, they are here today in this workshop, Nikos from CERT. It was very nice working with all of you, of course, and the team of George and Aristotle University, and we hope we have a follow-up. We have the capacity. I think we can go and have a very good follow-up and contribute to the city's district heating system. Thank you very much.
And thank you for your contribution.
Okay.
You have a significant role in this project concerning the intermediate technical person between the IAC and the industrial and research partners. And we're very fortunate to have you here, and I will keep your last optimistic message.
Okay, thank you very much.
Thank you very much.
Thank you.